Okay guys, so today we learned about interval and set builder notation and how to write it in the two. Let's fill in the blank for each of these 5 questions. In interval notation, bracket 2, comma 5 parentheses represents the set of real numbers between 2 and 5, including 2 because it's a bracket, but not including 5 because it's a parenthesis. In interval notation, parenthesis, -2, comma, infinity, parentheses represents the set of real numbers. If you're going from -2 to infinity, then you're getting bigger. So this would be greater than -2. In interval notation, parenthesis, -infinity, comma, -1 represents a set of real numbers that is less than, because you're coming from -infinity all the way up to -1. So all the numbers are smaller than -1. The set of elements common to both -infinity, comma 9 and -infinity, comma 12 is, so it's basically going to be everything up to 9. So -infinity to 9 are common, and this represents the intersection of both the intervals. When you have stuff in common, that's the intersection. The set of elements -infinity to 9 or -infinity to 12, or in both sets, is -infinity to 12. To include everything, and this represents the union, so this is both sets put together. They don't have to be overlapping, they don't have to be in both sets, you just want everything from the first set and the second set. Okay, so let's look at graphing these and writing them in set builder notation. So I've given it to you in interval notation, we want to write it in set builder. Remember that set builder is always going to start with a squiggly bracket. You're going to have an X such that, and then in this particular one, you want all the numbers between 1 and 6, and you do not want to include 1, but you do want to include 6. So 6 would have the little bar underneath the inequality. Remember that your inequalities are always going to be the less than sign, or less than equal to. So when we graph these, let's put 1 here, 2, 3, 4, 5, 6 here. We're going to do a parenthesis here and a bracket here, and you want everything in between. So this is how the graph is going to look. -5 to 2, again, little squiggly bracket, which is a brace, X such that you want to go from -5 to 2, and we are including -5 because of the bracket, and we are not including 2. So less than or equal to X less than 2. So if I put -5 here, I'm going to do a bracket. This would be 2, parentheses, and we want everything in between. -3 to 1, brace, X such that, -3 to 1, brace, and both are included, so both are going to have the equal to underneath. Put -3 here, 1 here, both braces, and we want everything in between. Sorry, both brackets. 2 to infinity, so this is every number. Again, we're going to start with a brace, X such that, but 2 to infinity means that you want all the numbers that are bigger than 2, because you're going all the way up to infinity. So we don't use infinity the way that, or we don't write this with, when there's an infinity, we don't write this the same way as if there's a start and stop ends. Because infinity is never ending, we're going to write it as one inequality, saying that the numbers are either greater or less than 2. In this case, since it's 2 to infinity, we want everything bigger than 2, so we use the greater than. because it's a parenthesis, we are not going to put the equal to underneath the greater than sign. So we're going to put 2 somewhere on one of these, put a parenthesis, and your line is going to go on forever. So make sure you show me an arrow at the end of that. Okay, coming from negative infinity, this means, again, we're going to start with x such that, and in this case, we're saying that x is actually less than 3, because we want all the numbers from negative infinity up to 3. So negative infinity is the smallest number, so that's all numbers less than 3. So find 3 somewhere on here, or label 3 somewhere on here. We're going to use a parenthesis, and we are going to go to the left because we want all the numbers less. Okay, on these last few problems, you're actually doing a union or an intersection. You've got to look at the symbol. And we've given you a graph there in order for you to graph it out so that you can find what the answer is. The answer should actually be in interval notation. So the graph is not the answer. The answer is an interval. So on this particular one, we want to go from negative 3. So we're going to make that negative 3 and this 0. And we want to go from negative 3 to 0, so that's here. But then we also want to go from, we want an intersection with negative 1 to 2 with the brace, or bracket, excuse me. And so we want that. So what we're looking for is we're looking for the overlap because we want the intersection, which is just this little piece right here. So our actual answer is going to be a bracket, negative 1 to 0. This is the only part where they're overlapping. So you want the green and, the red and the blue. And we're going to 0 with a brace, okay? In number 12, it's the same problem, except this time we want the union. So we want everything, which means that if we started this over here at negative 3 with a brace, and we basically ended over here at 2. Remember, union includes everything from both. We want everything in between. So the union is going to be from negative 3 to 2, the bracket. Okay, looking at the next one. We're going from, again, we want an intersection, so let's graph both of them. First one is coming from negative infinity up to 5. So I'm going to make 0 right here. So here's 5. So negative infinity up to 5 means that it was coming this way. So it's all these numbers. And then from 1 to 8 is going to be from here to here, and we are having brackets right here. So if I'm looking for my intersection is going to be where the 2 overlap. Okay, so it's going to be from here to here. So my intersection is going to be from 1 to 5. Looking at that same graph and wanting all of it basically, because a union means you're going to include both graphs, we're going to go from negative infinity. Remember, infinities use parentheses all the time. And, oh, sorry, it's not the same numbers. Just kidding. Let's start again. So let's look at graphing 3 to infinity. We're going 3 to infinity, that's going to be here. And then we're going to graph 6 to infinity. And that's going here. So if I want the union of the two, that means I want everything from start to finish. And so it's going to end up being 3